any other values. So we have to be critical, and why they are missing. What is the explanation of the missing? Is the person or data source is not available, or the person you ask is not in a good mood and did not fill it up, or what is it? Yeah. So we have to be careful about this type of aspect. So that is the pre-processing of your data, where you want to understand the structure of the data, and you will decide that time, okay, I know my data, I have to think about many things like machine learning or traditional way of looking at it, or deep learning, all these kind of things. Yeah. Okay. Now I said formal statistical models, but is definitely extensible. So I would say formal machine learning or deep learning kind of thing. So in this category, I divided the data in 4 different parts. Okay. Number 1, descriptive analytics, predictive analytics, prescriptive analytics, adaptive and autonomous analytics. So these are the different steps you can consider within the analytics domain. Okay. Now question is, what is the difference between them, and when should we do what? Yeah. So descriptive analytics, as I said, these are all about what is already happened, and the predictive analytics, what is going to happen. And prescriptive means if you change one thing, if you change one parameter, how it is behaving. And the last one, which is the very high level, where people are using actually deep learning and agent-based simulations, is a real time. Okay. So patients are coming, COVID, non-COVID, real time. Okay. Patients are coming, you have to make the decision now, because you have to save time and future studies. Yeah. So like Google Car is example of, the adaptive and autonomous analytics, where data is fed many years of data in the pipeline. Okay. Then let's talk about the input data. So you also need to understand what is your input data. Okay. Now input data can have a different structure. So I'm giving one example here is a matrix form. So matrix form means you have your features, you have your samples. So that is your structured data. So that is your structured data. Yeah. And sometimes in the healthcare domain, if you are talking about many biological data, it's a very much untargeted. So in a single experiment, you will get maybe thousands or millions of features in a single experiment. Yeah? So it is very important how you think about your analysis domain. Now, talking about the input data, input data can be many different forms. So for example, the first cartoon I made, there is no any outcome variable. Okay. Second one, you have an outcome variable, which I call response, your Y, and Y can be your binary, Y can be multi-class, Y can be quantitative as well. So you want to link them. So for example, here, I just wanted to show you, this is a very continuous kind of outcome variable. For example, age, and you want to link some clinical or some features with your age, for example. Here, maybe cancer stage 1, stage 2, stage 4, and it become multi-class problem. The third one is a multiple different format. You have same patient in rows, you have a different types of data, maybe clinical data, non-clinical data, and you want to combine them. So these are all the scenarios you might come across in the analytics domain. And you need to think about what type of method you are going to use. So going back to the next slide is some examples of the machine learning algorithms here. So we can classify the machine learning algorithms broadly in 3 categories, like supervised, unsupervised, and reinforcement learning. And then you can see what people are doing last few years. This is a data from this paper, Jiang et al, and they showed in the healthcare domain, people are using support vector machine around 42%, neural net, and others they are using, and you can see the percentage of a method is using how much. But nonetheless, one of the things is missing in this. They did not take into account, the industry. In industry, people also use, but we don't know because it's an IP related thing. But maybe the figure will completely change if you consider the industrial industry competencies or industry. Yeah. So in models, the one of the basic, whatever I showed, they either they two things. Either they do a kind of a regression, classification, or pattern recognition. Within the pattern, how you best you can define with your models. There are many other models can be considered as a machine learning, like this is the decision tree model, where you wanted to see apply the decision tree based method and wanted to see which are the important features and what are the predictability of your data. You can use the unsupervised one, for example, clustering, PCA, and many other things, just to understand what are their structure. We talk about artificial neural network today little bit, and then this is a kind of inspired by the biological evidences. So you can see there are different neurons, different layers. There are some activation functions, and initially, and you got some sort of predictions there. And a more advanced version of this is the deep learning thing. So in the deep learning is like people are using deep learning and different versions of deep learning, like LSTM, recurrent neural net, and GAN. GAN is also becoming quite popular nowadays. But mainly you can see that the people have been used this type of approaches quite a lot. And you can see how many times people use within deep learning, the deep neural net, convolutional neural net, recurrent neural net. So this is just a histogram, how people are using. You can see there is the trend is changing quite a lot. For example, the recurrent neural net people used in 2014 in the literature around maximum times. Later on, people move into convolutional neural net. So these kind of things, and these kind of things are happening around the globe. But one of the important aspect is, how do you validate your model? Okay, so people do ask you, okay, you run your model, how do you validate your model? I think this might be very basic for some people. So the validation, we always talk about external validation. Okay, so we don't talk about validation, the data given to you. So is data given to you? Idea is you make your own model, you predict, data is not given, and that is the ideal way to do the validation. So we call it external validation. And there are different kind of trends. Yeah, how do you split your data? Because there are many hyperparameters. You need to optimize each of the parameters. Like in decision trees, you need to decide on how many trees are optimum, how many number of trees are optimum, how many M-trie, N-tree, and this kind of calculations. In artificial neural net or deep learning, you need to think about how many layers you are going to use. Yeah, and that can be done by the cross validation or leave one out. There are many different ways people are using in the literature. Yeah, and then you measure the performance metrics. The performance metrics is by the confusion. We call it confusion metrics or contingency table. So it gives you a sense about true positive and false positives, which is very important. You want to get an estimate how many how model are accurate. So you estimate your true positive rate, false positive rate, specificity, sensitivity, and the ROC curve, and all these aspects there. So what I'm telling in summary, your first motivation, why we are using AI, different classes of AI, different machine learning algorithms, validation, and performance, how model is behaving, good or bad. Okay. Now, once you get your results, you might want to interpret your results. How do you interpreting your results? So remember, these are the 5 principles I talked about. This is the, I think, 4th one. And you are now interpreting your results. So you want to revisit your original question. What you wanted? Is it directionality? Is it magnitude? Is it uncertainty or standard deviation from the model? Develop overall interpretation. So your interpretation would be the overall. Okay. For example, my educational background is very multimodal. So my undergrad is electrical. I did biology in my master's, and then I did machine learning in my PhD. So I kind of going every time back and forth. Yeah. So your domain expertise is also important. So if you are working in the finance domain, you might want to involve someone who knows finance. And you, as a AI expert, your job would be to bring those results and discussion. And what do you think, is domain expertise aligning or not aligning, this type of thing. And then how you take the actions once you get those kind of thing, and is it actionable? Can you take actionable? If you want to take action, from the results, what need to be changed. That is important. Yeah. So that's the differences between the theoretical AI and applied AI in this area. And then finally, you wanted to interpret or communicate your results because people who are doing AI expert, usually they come from the computer science background or mathematical or statistical background. And then, for example, there is a tendency to, because you know your domain so much, you tendency to use different jargons. So the idea is you fuse your jargons. If you are talking with a clinician or medical science doctor, they don't care about your jargons. They care about, can it be applicable? Can my patient really survive? Can I use it in a clinical settings? So you have to make them understand the way they want it. So the way I do, I make a lot of figures, make tables, and try to avoid my jargons. So that's the way I mitigate my different stakeholders' concerns. Now, AI is good. AI is an elephant, everything. Okay, AI is solving everything. But nonetheless, everything comes with a price. I mean, in life, anything comes with a price. You have to pay the price for that. The question is how much you are paying. Are you ready to pay massive or small? Okay, there are concerns. Concern is your noise. Your data is not like, the data is created by us. So data will be noisy. So there will be variability in your data. So your measurement error, your sampling error, your heterogeneity, your dynamicness of data will be there. Okay. So be careful about what you are trying to achieve. Okay. So in the mathematical way, if you can see, if you can look at your effect size, so effect size means if you are looking at, okay, for COVID-19, the gender matters. Okay. Male get affected more than female. But then how much effect, you can estimate your effect size. So effect, I mean the regression coefficients or some sort of coefficient, some weight. However, that is your original thing. You will get some sort of deviation associated. You will never get the true value. Some value will be associated because it is very difficult to dissect this value. People are using many different models like linear mixed model, causality, Bayesian, but whatever you do, some of the part of your model will be unexplainable. You cannot explain it. Okay, so we should take into account that effect size in the data. Okay, and then if you look at the pipeline, so if you look at the pipeline is following. So you have the question, you design your study, you generate data, you pre-process data, you apply statistical machine learning, you select some feature, and the knowledge discovery. Remember, in each of your steps, your error get multiplied. Your error get multiplied, and the error is coming here as well with your knowledge. Okay, so it's very difficult to dissect these error. So we have to be very careful what we are looking for. Yeah. So what we are looking, actually, eyes of the tip. We are not looking many of the things hidden in your data. The reason I am telling you, so you have to be careful about the deep learning, whatever you are using. You cannot, you can tell we use deep learning and then we got it. But remember, there is a heterogeneity, there is a variability. Probably we could not explain that part. Okay. All right. And then data privacy and ethics. So data privacy, I mean, who authorizes your data? Where you are getting your data? Can you take another patient's data for your analysis? Who authorized? So this is a very, if you open the Nature article and you keyword and you type in, the data privacy ethics in machine learning, you'll see that even in UK, we developed a different thematic area, data privacy and ethics. Okay, so I'm also part of HDR for Health Data Research UK. It is a huge grant, government of UK established for 5 years, and they made a thematic area, data privacy and ethics. So the job of them, looking at where data is coming from, can people like me can use the data. Okay, so it's very important. So it doesn't go away. I mean, we have to take into account very seriously. Okay, so far I have talked about very general thing. Now I'm going very specific thing. Okay, very specific, very specific about certain topics. Now what I did, all the case studies are taken from the, as I said, Lancet, New England Journal of Medicine, and they are interdisciplinary. What does it mean? You will see massive amount of artificial intelligence applied in multiple different domains. Okay. Now, all the papers, as I said, so for example, you can see the first one is in Nature paper. Okay. Could COVID-19 help refine AI, data analytics in healthcare? Okay. And all the these are last 3 months old paper, or maybe even last week. There are papers, I think 30th of July, I'll show you. I mean, and every day they're publishing the new papers. And you can see the data in the right-hand side, small table, 2003, 2 papers on COVID. 4, 1 paper in PubMed. 6, 7, nothing, because nobody knew COVID will be enormous. Yeah. And I think the 2003, this is about the SARS virus or something came up in China at some point. I think probably that one. 2020, 522. And I'm talking about maybe 3 months old data. And now it become the double actually. Okay. So you can see the massive amount of the data is came up in the literature in last few days. So what these papers are talking about? These papers are talking about how we can use the AI to solve the problem. Applied AI. We're not talking about so much in the theoretical AI. We're not developing, we can tweaking the method. We can do the neural network, little bit of tweaking to work for us, but not that someone is going to, identify new neural network. No, we're not talking about that. Yeah. Okay. First case study, artificial intelligence tools related. So this is the tools related, infrastructure related. So these data, so you can see the 9 June 2020, this is a technology feature in the Nature. And they say what people are doing around the globe to make infrastructure for COVID-19. So you can see, again, you can see the January 2020, February, China just closed down, and other countries, they are locked down in the process. And you can see what is going on, total COVID-19, and then portfolio, and then you can see peer-reviewed article preprints, and quite a exponential growth in that. Yeah. Now, if you read this paper, artificial intelligence, what they're talking about what people did. Kaggle, they made a Kaggle competitions for COVID-19. Google COVID-19 Research Explorer even. Okay, they made it. COVID Scholar, developed in Lawrence Berkeley in California. Okay, Spike Code focuses not only in the retrieval of the paper, but extraction of information from them using a simple query language. Simple query, maybe SQL, and in the backend there are quite Oracle and different others, but just to make use of the other people. So this is one of the example I want to give for infrastructure. Okay. Okay. Then next one, the next one is about the natural language processing. Okay, knowledge map. We talk about a lot about knowledge map. So you can see. So what this guy did, I think this is the group from the Mexico, and this Mexico, this paper is not published yet. This is the archive paper, so they probably will be published soon. So they did some sort of natural language processing. They looked at the word, how many word people are using in the abstract level, in the titles, and in the keyword. So you can see the patients, nCoV is coming up quite high. COVID is coming up, coronavirus is coming up in the air. So why they want to do that? They want to do that because they want to create a knowledge map so that people can be easier. Yeah. And not only that, what they did, they make an occurrence of the ontology. So if you look at the graph in the computer science, or if you are discrete mathematician or whatever, and we do use quite a lot. This kind of thing. So you can see the graph, the sizes of the graphs is about the frequencies of the article co-occurrences, and the link between the disease outbreak epidemiology. You can see they are quite a red color one. Now the green color one, the green color was not, and the blue color one, they are not exactly same. They are a little bit different because they are not co-occurring with this one. I don't know why, but in my impression, I would guess that maybe the human will be associated with. You can see the coronavirus infection is not associated with human. I don't know why they made it. I was thinking other. Oh yeah. So human and human. Okay. So here is a human. So the big human, the big one is for the coronavirus related, and this one is non-coronavirus. There are some link between that. And if you look at the authors, who are the connecting the authors, you can see the Wang, and these are the all Chinese authors. Initially, they published those data sets. Yeah. So this is just one example for the knowledge map. And then there is another paper came out in Cell, and you can probably read proteomic and metabolomic characterization of COVID-19 patient serum. This is very biological paper, but nonetheless biological paper because they applied AI in molecular data. So what they did, they used the patients, and they identified different proteins and the different metabolites which are unique for the COVID patients. So, and then you can see here, there is a small cartoon. these are the data from the patients. This is, the experiment they did, and this is your classification. So they use, you can see the small, this is kind of a PCA showing evaluation and the machine learning tools. Yeah. Now, this is a little bit detailed, but you can see what I said earlier is coming back here. So these are your patient characteristics. So you can training cohort. So the training cohort, as I said, data, you are creating your model. So that is your training. Okay. And they used testing. They use the testing in the independent, you can see the test cohort, only 10 patients. So number of patients are very low in this case. So question is, can you apply deep learning? Answer is no, you cannot apply deep learning in this type of settings. So you have to use some sort of, so they use a random forest and they want to understand biological mechanism. So their question is different. They want to make a model, but they also want to understand the mechanism in the biology. So they use the deep learning or machine learning for biological mechanisms. So you can see there is a little graph. So those who are from biology, they might be recognizing. Those who are from computer science or mathematics may not be, but doesn't matter. If you're mathematics, you interpret as a graph. Those who are from biology, they will interpret as a pathway. Okay, but these are the novel pathway they found. And you can see these are the transcription factors, enzymes, different color representing different types of data. Okay, and then remember I talked about the AUC so you can see the AUC value 0.95, which is AUC is a combination of specificity and sensitivity. And you can see this value is coming up 0.95, which is quite good model. Yeah. Okay, next move on. So this paper, it came out in Nature Biotechnology, which is around 40-45 impact factor journal, came out 30th of July. So last week or maybe 2 weeks back. Yeah. What they did, this group is from Chile. Yeah, Latin America, Chile. What they did here, and they mentioned about, and I try to highlight what is important. So this is the abstract level reading. Okay. Now, laboratories in developing countries. So for example, India, we are also a developing country. Yeah. And what they did, they took a nasal swab and they did a MALDI. What is MALDI? MALDI is a high throughput experiment called matrix assisted laser disruption ionization mass spectrometry. So this is a quite long name, but you don't have to remember the name. But what I'm trying to say, this is a high throughput experiment. So they are claiming you take a nasal swab, okay, and you do some sort of targeted measurement like MALDI, and then from these you can identify the lead, and you target those lead for COVID-19. Okay, and they found actually this paper is quite good. I mean, they're quite good in the sense they applied, I think, 5-6 different machine learning method, and they claimed support vector machine provide highest accuracy. Okay, so and they applied random forest with feature selection, without feature selection, all these different strategies. Okay, so this is one example, I would say, also more on the diagnostics level, but also how people in the developing countries they can achieve, the first accurate way of doing the experiment. Okay, next one. Artificial intelligence enable rapid diagnosis of patient with COVID-19. This is a CT scan data. I think the Vice Chancellor sir mentioned about the X-ray. It's very similar to these settings. They published in Nature Medicine. So Nature Medicine is of course is a quite good journal. But then in this article, what they did, they used the CNN model and the deep learning model. They combined CNN with traditional machine learning, and they showed your ROG value, your predictability value increases if you combine 2 different types of modeling approach. And data is coming from CT scan imaging. Yeah. And then they have a collaboration with hospital. Of course, you cannot do it alone unless you have a collaboration with hospital. So again, this is the interdisciplinary area, which I want to emphasize that this type of, if we want to publish a very high impact, we need an interdisciplinary approach to solve this. Not just computer science or not just biological science as such. Okay, next one, mobile data, smartphone. So this paper came out in 8th of July, and this is for Nature Scientific Data. Okay, and in Italy, so data is from Italy. So you can see how when the people got a lockdown, how people use their mobile data. Okay, very interesting. So they use smartphones. You can see how many 170,000 patients, massive amount of patients, yeah, and how their activity, what their preferences are changed. People people, for example, typing a lot about, you know, the traveling, but when COVID-19 happened, lockdown happened, people are not talking about the traveling. They're talking about maybe takeaway food more. Yeah. So understanding the need for people will give you added advantage what people need, so you can serve better. Yeah. So what they did, the design of their study is a pre-outbreak. So they take the data, each day data, 17, 21. So, but this is not shown, but they took a massive amount of data. Non-essential industry halt in this time period, stay at home, school closure, so this data is all about this one. And I think, and they shared the data to understand the trajectory of the pandemic. Okay, and then they said in this paper how we can make a better healthcare decision from the smartphone data. Okay, so this is one of the example. And so I try to give a molecular data, imaging data, mobile data in, you know, multiple different use cases. You might want to look at those papers if you're interested how people are using those data sets. And this data is free. You can download and do your own analysis. Okay, so I covered the next bit. Now next is how we are involved, how I am involved in this type of COVID, because my involvement is hospital. I am working for 50% hospital. I'm also working 50% university. But also apart from that, I have my own business, as you know. So I'm trying to jumbling around and trying to maintain the equilibrium. So what we did in this, we are collaborating with NIHR Global Health Research Unit called Global Surgery. Now I have to introduce what is Global Surgery. Global Surgery is a international effort, and they are all over the world. And we have a hub. We call it hub, and we are focusing mainly on the developing countries like Ghana. India also we in the Ludhiana in Punjab we have a hub. Johannesburg in South Africa, Nigeria, Rwanda, Birmingham, as an Edinburgh University. So we have many trials in the surgery. So they are specialized in the surgery level. Okay. Now, what is happening here in the surgery is what is happening in the surgical point of view. So in the COVID-19, you know, this is a respiratory syndrome. You get once you infected, first few days no symptoms. 14 days onwards, there are some symptoms started. Based on the subtype of the virus, you get a different types of respiratory aspect. Okay. So and then you might need operations as well. If you are suffering from multiple different diseases, you may need surgery as well. So what we did, this is the work actually by my PhD student, Laura, very talented PhD student. She is from biomedical engineering, so but focusing on the inflammation. So she understands computer science, she understands mathematics, she understands inflammatory biology as well. So this is a very interdisciplinary in a way. So they have given us 4,525 patients, okay? And they measured 16 clinical aspects. So they measured age, gender, you know, respiratory syndrome, previous respiratory syndrome, cardiac syndrome, if there are any cardiac. And they also estimated the mortality rate in 30 days. 3,569 patients died alive, and 956 patients are dead. Okay. So the question is, can you identify some sort of what are the important aspect of this out of 16? Which one is important out of many 16, so that we can prioritize our decision making. So what we did, we developed a tool. Okay, we developed a tool, and if you see this tool is exactly similar the way I described the data analysis pipeline. So data set, exploratory analysis, select important feature, model generation, model deployment. Okay, and once we develop this one, these are the results. So you can see these are the bar diagram. You can see the levels of the feature. Each of the features are drawn here. You can see which one is alive is red, dead is green, and you can see, for example, if I take a gender or sex, you can see the male. There are percentage of male people who are dying. You can see, you can look at the and this is true for not only for these data. I think this is true for other Italian data or Chinese data as well. Okay, and also you can look at the pattern, what is happening here. You can see anesthesia, so general regional anesthesia. If you look at the general anesthetic, the people are dying if already have this one. So we have identified a couple of other important parameter from this data set. And then more little bit detail about the result. So what we did, we took the 16 features, we run multiple different models, including generalized linear model, which is a part of traditional statistics. We use the random forest, we use support vector machine. I think we run around 5-6 different types of, including artificial neural net. And we did a combinatorial, okay, combinatorial analysis. Single, which one is give you best? Take combinatorial combination, gender with any other clinical features, and see how much your accuracy is coming up. So the best we got is with the GLM, generalized linear model, the gender or sex, ASA2, which is a parameter, respiratory, and age group. So age is also important. And I think you already know age is also important. If you are more than 40 or 50, you are more prone to get COVID-19 because of your inflammatory markers in your body are not a pro-inflammatory, they are not activated compared to the 20 years old person. And you can see the AUC curve, how it is 0.71, and this is the ranking based on AUC, all the combinations and the model and the model. You can see here in the model a different run. We run 1,000 times. We took the mean of AUC, not a single run, a multiple run. We estimated standard deviation and all these things. And these are just a visualization of this table. And then what we did, we made an app for this kind of real time. We made an app because we know now what are the things is happening, which are the important parameter we should take into account. And we made an app so that we can help the clinical people there. Okay, so what I'm trying to say is AI, machine learning is just a tool. Question is, where do you want to apply? Yeah, so data is a fuel. I mean, you have to understand which is a petrol, diesel, or what type of fuel it is. Where do you want it to apply AI? Yeah, and definitely this is an interdisciplinary research. So I'm wherever I'm going, I'm emphasizing this fact. It's a combination of amalgamate of computer science, clinical science, statistics, data science, or whatever you call it. But this is really a joint effort. And then it is very clear from the research is a combination. It gives a very high impact. It's very high impact. Nature medicine is not a joke to publish Nature medicine. I mean, Cell, Nature, these papers are really, you need a massive cohort. You need a equal contribution coming from the clinical science, equal contribution coming from mathematician, equal contribution coming from computer science. And then you make an impact on that. And then that is my definition of the interdisciplinary science. Of course, I am doing quite a lot of things here. You can see we cannot also rule out the social science aspect, because social science gives you the practical. Can you implement in our society or not? Okay, clinical science and basic science, they are kind of a linking with each other. And here, this is published in 22 May, and the Nature Machine Intelligence Journal, which came out, I think, very new compared to other Nature journals. So they said machine learning for COVID-19 needs a global collaboration and data sharing. Okay, so data sharing becomes an ingredient of the research nowadays. COVID-19, due to COVID-19, we're doing more, but in general, for example, if I have a cohort from type 2 diabetes, I would like to see how North Indian population are affected, or South Indian populations are affected in type 2 diabetes. What are the clinical features? What are the microbiome or bacterials are different in this kind of journals in the aspect. So just for your information, how people are emphasizing this kind of thing globally. Yeah. Now, very last point of I would like to talk about a little bit of collaborations, and this is boiling down to my earlier conversation of interdisciplinary science. So I have been collaborating with many different universities over the years. So that is, and as I said, I really talk about these things, and which is very important. And then what we did, and same applies for the people from India. I could not achieve that much of collaborations in India, and that's why they are not in the list here. I'm still trying to do something with India, but somehow something is happening. I'm not able to proceed. But however, it's not only just collaboration. Okay, we have to maintain, we have to make our stakeholders make work. Why Harvard people will be interested in me? If I am saying, okay, I'll work and I don't do anything, I have to show proactivity. So we made some progress. We have, for example, this Journal of Neurosurgery. So it looks like it's a medical journal, but it is not. I literally use the support vector machine, and the patients are coming from Harvard, patients are coming from Massachusetts hospital. So these are USA population, but machine learning applied in those. So these are international, interdisciplinary journals, okay? This one paper came out in I think 2 weeks back, just accepted. You can see, if you read it, you can see these are very, very biological, but if you read it, it is not, okay? So this is the collaboration with the University of Cambridge, with Latin America, with Colombia. I recently published one paper in agriculture, okay, on image processing. So what they do, they're using the drone for plant phenotyping. Like we measure patients, they are measuring the plant. How much is the plant height? How much is the, you know, stem root, all this measurement. They are saying employing if they employ someone, it's very expensive. So they are using drone, they have an image and massive data, they wanted to understand. So we developed, you know, the automated pipeline, and we published in the plant method, okay, and we use deep learning there, because you have a massive data. And some extent, the problem is image analysis, some extent the problem is also prediction as well. Molecules, we published with University of Parma, Italy. This is the polyphenol, okay, the coffee. So it's very, you know, you see the diversity, yeah, where you can apply AI. What, I mean, espresso coffee, which coffee brand is better? Because this is an industry project. The people who are making coffee like Espresso, Nespresso, Illy, those companies approached this group and then say, okay, I want to prioritize my coffee group. Which one is it? So it's very interesting. Then the diabetes, of course, this is clinical. And then there are a couple of papers which are in the pipeline. And what I wanted to say is you can see the varsity, I mean, the variety of applications, and you literally can impact using this. But nonetheless, we have to remember where we are going to apply, the pitfalls, and all of the things. And lastly, what I did here is I mean, lastly, this is a very new, I developed an Omix Marker, and I have some other consultants working here, and diagnostics using AI, artificial intelligence, how we can make a better healthcare. That's the question we are trying to solve. Yeah, and definitely interdisciplinary. So we have a person we call in the biochemistry background, nothing to do with AI. We just kept it because we wanted to get more feedback on the biology. Yeah. Okay. Now, how do you work? So there are a few links. I mean, I would say, I mean, even for me, if I want to work some people in India, so what I look for the 3 things: Newton Fund Scheme. The Newton Fund Scheme is a British Council. So this is a collaborative work. The PhD students, 2 years, they spend in UK, 2 years they spend in India. Okay. And then all the costs are taken care by British government, British Council. Yeah. Very competitive, but there is opportunity where there is a collaborations can make. Vajra faculty. So I'm applying, I've been trying for Vajra for a couple of some NITs. Gyan for teaching, but then it's not only for teaching. If you teach, you interact with the people, and then you develop a proposal, and then you submit in Vajra, or maybe DBT grant or DST grant, and so on and so forth. Okay, and finally, these are the group. I'm leading the Omix Analytics group. I'm reporting to my director, HDR UK director. He's my director, and there are people. I have 2 PhD students, 2 postdoctoral fellows working many different universities across the globe, and I'm very grateful. They have shared their data, and I would like to increase this list, of course, and would be great, and then make an impact. That's the ultimate goal, that how collaboratively, and you can see nothing to do with inflammation. I mean, I don't know anything about inflammation. I mean, but however, if we know what problem they're facing, I think we can contribute a lot. Yeah. And finally, I am very grateful for giving me this opportunity, and please feel free to email me if you think I can do something or we can collaborate something. I am a visiting professor in NIT Calicut. I come sometimes, and VIT as well, NIT Suratkal. So I'm a little bit involved, but I would not mind to come anywhere, you know, and share the knowledge and make a very active collaborations and make a culture for interdisciplinary. So that's my goal. Yeah, and I hope you have a lot of questions, and then I will try to answer as much as I can. And thank you very much for your participation. I am very much grateful that I have given this opportunity to share my experience, and of course, small experience. I have not that experience so far, but whatever it is, but I hope maybe it is a little bit of useful. And thanks a lot.
Yeah. Thank you very much, Dr. Animesh Acharji. You have explained very nicely, and I am thankful to this particular digital platform that when we organize the sessions offline, then coordinator has to run here and there for some arrangement, etc. But today, very coolly, I could attend your session, being in spite of coordinating this. So it was a great experience. Mistakes increases your experience and experience decreases your mistakes. If you learn from your mistakes, other will learn from your success, and hence never complain about the difficulties in your life, because the director God gives the hardest roles to his best actors. Thank you, Dr. Animesh Acharji, for your insightful presentation on the webinar topic. You are truly a motivational benchmark to the youth of the world. Thank you very much for your excellent elaborative delivery on artificial intelligence and motivating the audience for innovations. Looking actually, there are lots of participants who have in Zoom platform. So if I mute all them, then there will be a chaos. So I have picked up some questions from the chat box, and we will go through the questions one by one.
Yeah, great.
Yeah. So, I would like to ask from on behalf of participants that you told about Omix Marker, that it is a data to diagnostics. So, what exactly the role of this? Like data to diagnostics means you are collecting the data, or you are processing the data, or what exactly it is?
Yeah, so we are doing both. Okay, so what we are doing, we are developing the platform. We are developing the platform. Data is coming from various resources. These are the molecular data and non-molecular data. And some people, like stakeholders, are coming to us saying, okay, I have got my data. Can you tell me something? We say, okay, we have got data. Would you like to try our data as well, including you? So we fuse independently the data and try to see, okay, your data got this one. So we start from the collecting, but also this data is collecting from all the public resources. Yeah, and the stakeholders bringing their own data set. So it is starting from collection, processing, and knowledge division. Yeah.
Okay, sir. Thank you, sir. And sir, just moving ahead to the same topic, that whatever data, let's say, suppose if we have our data, and is there any specific format of the data which you require, or it can be any raw kind of data which you accept?
Any data, any kind of data, any kind of data. So structured, unstructured. Now, if it is unstructured data, what we have to do a little bit different process.
Okay.
Yeah. If it is a structure, then our job is little less. You know. So if you're bringing Excel sheet, yeah, then we do some processing and then we move ahead. But then if it's unstructured, our job becomes a little more. But we can work on both the things.
Yeah. And one more thing, that when we work with AI, the great that is its limitation is that we have to have a large amount of data to work with AI to reach to some conclusion. So what will be the authenticity, because when we approach to the Indian hospitals, etc., for data for research purpose, then it is not so easy. We do not get the data easily.
Yeah.
So how to handle this particular problem?
Yeah, you are right on. You're right on the main problem. Actually, that is the problem in especially in the Indian universities and the hospitals. What I say, because what I see here in UK, university closely work with the hospital. Yeah. So your first barrier is gone. Yes, so what is first barrier? First barrier means they know us. If I am going now and I am saying myself, I am coming from University of Birmingham, and go to Nottingham, or not Nottingham, and then say, you are university hospital, you are saying university hospital. And they say, okay, we are university hospital, tell us, what is your problem? That is the first step. Doesn't matter what you talk. You have a coffee maybe. You see what I mean? But this is the recognition. This is the first thing. Okay, they will recognize when I go there, they will say, I am not an invader. I am not a third person. So they got a little bit of, assurance. And then I started talking, look, I have a project, these things, I have the data. I am interested to look at your data. can you give us? I am ready to help you in terms of the logistics, like writing the DTP, data transfer agreement, on all these type of things, confidentiality, now GDPR, and would you mind to share with this? And they will say yes or no. And more probably they will say yes, because they are from the university hospital. Their job to promote the research. In India, what is happening, they are a little bit disconnected. Although there are few places they are connected. I mean, I have not seen so far the data coming from the hospital, and they are working very, very closely. Maybe there are a few groups, and not as massive as we are doing. And that's why you can see this is the gap. And I think how you can mitigate, you have to involve the clinical people before you write a project. You have to involve them, and also there is a bureaucracy. I mean, who we are talking? If you are talking to an MBBS doctor, they say, oh, I'm not boss, talk to my MD boss. Now you have to go through who is the guy who is authorizing, who is the guy who is making signature, and talk to them, make an agreement, because I'm in everywhere actually, this is a very lengthy process, transfer of the data, and making all the ethical aspects. But I think you have to involve them in the upfront.
Yeah.
And and that is the only way I could see. Otherwise it becomes disconnected, and impact is not that much you expected from AI.
Yes. Thank you, sir. You mentioned about data privacy and ethics issue also properly. But still, I would like to ask you one question. That suppose if we have everybody now is having oximeter, pulse oximeter, because everybody is so careful about COVID-19, etc. Everybody wants to know that what is our oxygen saturation level, etc. So suppose if we try to collect, because if now I have that device, small device, it is not costing much. If I try to collect the data from that particular device, and if I want to work on this particular system, now the instrument is authentic, but collection of data is done by me. So how do I authenticate that particular data? Because there may be ethical issues if I want to use the data for publication, or for some further process, or for some further work in this area. So how to handle this particular problem of the data which we have created, how to make it authentic? You got the point what I am asking? Because
I got the point. Yeah, so authentic, I mean we have to be very careful about, because I mean, as you said, we cannot touch or anything, and the device has to be properly installed to get the data. And I think it is very critical. This is your critical part. And if you look at the workflow, this is your step number one.
Yeah.
Making infrastructure correct. If it is not correct, whatever, doesn't matter what you do CNN, ANN, doesn't matter, whatever you do, everything is false positives. Yeah. So this is more in the practical aspect, actually. I mean, what you were saying, I would say, I mean, initially you will face difficulty, or you need to think about, maybe the patient will come, someone will come in isolation and then use the device and then go out, maybe something like this. You have to think about the strategies, strategy A, strategy B, strategy C. If A doesn't work, B, and maybe for A, you generate some data, for B, for reproducibility, you generate some other data set as well, and compare how reproducible those are.
Good. Thank you, sir. And the next question is that for AI, for machine learning, etc., generally at our institute or our level, we use MATLAB and coding-based programming for that. What do you suggest? What are the best platforms to work with these AI systems?
Yeah. So for AI system, people are nowadays using Python.
Yeah, Python. Yeah, now it has started. Now we have started using Python also. Python is our at peak. So you suggest that we should go with the Python?
Python, and it depends on the application. Python, it is easy. R, some modules in R. R is slow. Okay. For big data, I would not recommend an R. I would recommend R for very targeted analysis. If it is a big data sort of analysis, Python is very good. You need to secure some cloud computing aspects as well. So AWS or Amazon AWS or something, or some sort of cloud infrastructure, and of course the Linux platform. Your machine has to be very high terabyte machine, so that you can your running time maybe less and this kind of thing. So you have to take into account the infrastructure first for this thing. Yeah.
Yeah, good. Thank you, Dr. Saab. One more question that you talked about that if the data, massive data, if we have massive data, then we go with the deep learning thing. Is it only that whenever the data is massive, then only we use deep learning, or is it related to the complexity of the data? What do you mean by exactly massive? Because I'm just confused in massive and complexity word.
Yeah. Okay. So the massive and complexity, yes. Okay, thank you for bringing that. This is very important concept. So massive means you may say, you can say, okay, you have number of patients, maybe 1 million patients. 1 million patients, and you have got measurement, maybe 500,000 measurement, massive data. Okay. Now, complex means you get multimodality. You get a clinical data, same sort of clinical data. You get the same sort of other molecular data. So it becomes a massive and complex because you have to handle each of the modality of the data, clinical or biological. Okay. Yeah. So this is one level of complexity. Second level of complexity, you don't know yet what is in the data. Massive doesn't always mean it is nice.
Yeah.
You see what I mean? Massive doesn't always means it is nice to have massive because you don't know yet what is inside. If you're at 90% of the columns are blank, what can you do? It's massive, but blank. Then deep learning doesn't work anymore. I mean, 90% of data, this data is chaos. I mean, I would say you cannot work with this data because more than 50% data are missing, and you cannot impute the missingness because you can impute because it will be directed more how you impute.
Yeah.
So,
Dr. Atul, please mute the participants. Dr. Atul, I request participants to mute. You can put your question chat box. I'm picking up the questions from chat box. Yes, sir, please. Yeah, Dr. Animesh.
Yes.
So, yes, sir, please. You were continuing.
Yeah.
Sorry for the interruption. Yeah.
Yeah. So what I'm saying, the massive doesn't always mean that it is nice. So that's what I'm meaning. I mean, it may be chaotic. So you need to really understand and then see how it is behaving. Yeah.
Yeah. Thank you so much, Dr. Saab. Now, one more question. Moving ahead. It is related to the table which you have shown in one during your start of the presentation. That time some of the columns they were having 0 and some of the columns it was NA, not applicable. So not applicable means we are not sure what is the data, exact data is not available, and 0 means it is a minimum value of the data. But suppose if we want to use this particular data to learn our systems, then because we cannot ignore NA, we have to put some value. So how do we go with it?
Okay. So
because NA, you got my question, because 0 is having some meaning and NA is not having any meaning.
So I will ask who got this data. I would like to talk with them.
Okay.
I would like to talk with them. I would like to understand why this is NA. Is it NA? Is it because the measurement is cannot we cannot take the measurement, or we can? I mean, what is it? Is it, should I make a minimum value? Should I put a median value? Should I make a average value, or should I make a predictive model by KNN? We have to understand that. Some people do by average, some people do by median. But I would say I would like to talk with them to make this decision. Should I put in average, median value, or minimum value?
Yeah. Good. Good. Thank you, sir. Thank you. Any more questions? Now I think the questions are. One more question. Can you suggest some sources of data which are like latest data sources for COVID-19, which are the free sources of data which we can use for research work?
Absolutely, there are many. There are many. I mean, the person who is asking, I request if you can contact me directly. I don't know who requested, but then if I mean many of them have my email address. If you can email me, I would be more than happy to direct you in particular way. Yeah.
Yeah, sir. Yeah, I will
Yeah.
take it from you.
Yeah.
Yes, sir. Thank you, sir. And I think now no more questions. I couldn't see the questions. There are so many lots of appreciations for your sessions. Very nice session. Very well presented session. Lot many appreciations are there. So thanks to all participants for such appreciations. So these appreciations are for you. It
Oh,
is for your
okay.
presentations. Yeah, yeah.
Yeah, I'm interested.
Few.
Oh, great. Okay. Thanks a lot. I mean, I think one of the great strength is the audience. Okay.
Yeah.
I think you mentioned earlier. I mean, if
Yeah.
audience is not whom I'm talking. I mean, I usually make, this kind of coaching, or I mean, I also coach people as well, but this kind of things I face to face is much
Sir,
more is much more
Yeah.
interactive actually. So yeah, and thank
sir,
you very much. Yeah. Someone is,
Yeah.
yeah.
Somebody wants to ask that.
sir, I
So
have one. Sir, I have one question.
who is asking, Ravi? Is it Ravi?
Yes, ma'am. Yes,
Okay.
ma'am.
Okay. Go ahead. Go ahead.
Ma'am, I want to ask that question. If somebody wants to do in a job in a data science, then what are the
Hmm.
basic purpose and what are the basic training, or you can say courses we have to do for that, for like machine learning, deep learning? मतलब sir, ma'am, scenario क्या हो सकता है इन सब चीजों का?
Yeah. Dr. Animesh
Yeah.
Ji, would you like
Yeah.
to answer? Yeah.
Yeah, okay. I mean, the first question I will ask, what is your basic background? Are you 10th pass, or you 12th, and you are looking for undergrad, or you did already undergrad?
Sir, sir, I am BTech CS third year.
Okay, CS. So you know CS. Okay, so then what you have to do, you have to specialize you do a machine learning related the projects, because I can suggest you courses. Courses will give you basic information. Okay, people write they have done courses and all these things, but unless you have a real feeling, if you want to make your career, you need exposure. So if you, for example, if you wanted to do your final year thesis, I would say you take a artificial intelligence based thesis where you can show how the data is behaving. So that will give you a very, very practical aspect. And 6 months working in your thesis will already you are ahead. Yeah. And the companies, they will ask, okay, what you did in your thesis? And then it's opportunity for you. Yeah. And definitely to achieve that for 6 months, you need to take maybe Coursera courses, maybe the Udemy, or I don't know, data came, whatever it is, or MIT
Yeah.
lectures, or whatever. But these courses will give you the basic understanding. Now you are computer science. I believe you studied the theoretical computer science, data structure, and operating systems. You are good at that. Now you have to be a little bit serious about the mathematics, linear algebra, so that you can explain the model. Yeah, mathematical models. Yeah, so or maybe differential equation type of model, this type of analysis. So if you make stronger that bit, that will do a job. And also you need to think about where you wanted to make an impact. Is it you want to developer or scripting, or scripting the data science, or you wanted to do the infrastructure related cloud computing or high performance computing for the data? There are also a little bit of division there. So think about those lines.
Yeah,
Okay.
thank you so much. Thank you so much, Dr. Animesh. You have explained nicely. Actually, I have noted down because you have nicely explained on all the topics like stating and refining the question, descriptive analytics, exploring the data pre-processing, building formal statistical models, input data validation of models like external validation, concerns and data privacy ethics. So lot many aspects, almost all important aspects you have covered. And I think this is a good platform for students also and for the researchers also to go ahead with this particular takeaways from this particular session. Our director sir also is there. He is also attending the meeting. On behalf of our institute, I would like to ask you one thing, that because you are a best combination of biology and engineering aspects, can we have some sort of, can we are also having good students in our institute, and they are also, but they do not have the good background of biology. They a few of them, they do not have the big great good background of artificial intelligence. So can we have some collaborative project work with your Omix Marker or under your guidance?
Yeah. Absolutely. I mean, that is absolutely true. I mean, and that is I'll be very much flexible about it. And yeah, that's absolutely fine. I mean, the thing we have to do is define the project, define the scope, deliverables. What is the deliverables will be coming, supervision plan, how supervision will be going on, impact. So, I mean, any of the things you can see in my presentation, if I take into account or undertake some work, I would see as a paper, a high impact paper.
Yeah.
We don't go for SCI journal
Yeah.
or Scoopus journal. For our main objective is impact. It may be 10, 15, whatever it is. We go for high impact journal, and
Yeah.
we bring SCI Scoopus this in somewhere. So we need to design the project. We have to see, define the role, and then we have to see how deliverables are. And I'm very happy to take into account anything in this aspect. Yeah. Thank you.
Yeah, thank you so much. Thank you so much, Dr. Nimesh. Director sir is also here. Sir, are you listening us? Do you have any conclusive remarks or any comments or any suggestions?
Yes, yes. Are you listening me?
Yes,
Yes, sir.
yes, sir. Yes, sir. You are very much audible, sir.
Okay, okay. First of all, I am really thankful from the core of my heart for the nice presentation by Dr. Nimesh ji. He has
Thank you.
thoroughly explained and with a greater clarity the impact of AI in the society in the near future. It will be helpful to deal with lot many issues related to the society, whether it is from the healthcare, whether it is related to the energy sector, whether it is related to the environment, because you have to play with the data in a positive manner, and lot of important inferences can be drawn. One thing what he mentioned in his lecture, that the culture in US and UK, so far as the research is concerned, it is multidisciplinary. Most of the research is carried out in collaboration of medical schools. But here in India, we do not have such collaborations. So much so that in a single department, there are a number of the faculties having different areas of expertise. They are working in isolation. They do not discuss, because if they discuss, the expertise of one faculty member can be utilized for solving certain practical problems. So that culture is to be inculcated. I can share one thing, because Acharya ji is there in UK. I would like to mention here that my son is doing masters at the Cornell University at the moment in chemical engineering, and after his third year, he undergone a training at UK in Cranfield University, and he worked on the CFD, particularly simulation and modeling. He is focusing upon, and nowadays his research area is related to the diabetes, because as you all are aware that diabetes and the cancer are the two deadly diseases which are affecting the whole universe. So we have to come up with certain models which can be we can predict and can provide the solutions to lot many problems. So data from the computer science department, from the AI, from the medical schools, and others can be done in a multidisciplinary manner to solve the practical problems. So that way, Acharya ji pointed out very effectively that a multidisciplinary learning is required as on date, so that the problems of the society can be rooted out. With these remarks, I am really thankful to all of you for the participants, and I am confident the way he has explained the things, participants might have definitely benefited, and they will it will be helpful for them for deciding their future course of action in their professional world. With these, I am thank you to all of you. Thank you very much.
Thank you, sir. Thank
Thank
you
you,
very much.
sir. Yeah, thank you, sir. And now I think Professor D.K. Shrivastava, are you there in the meeting? Professor D.K. Srivastava, are you there in the meeting?
He's not there, perhaps.
Yeah, okay. Actually, Director Sir has eased my work. I'm thankful and grateful to Honorable Vice Chancellor, Professor Vinay Kumar Pathak Sir, for sparing his valuable time to be chief guest of this function and blessing us with his encouraging words. I'm thankful to our Honorable Director, Professor V.K. Tyagi Sir. Not only he inspires us, not only he motivates us, but along with us, he also attends the sessions and he also participate in the event with us and build our boost our moral. I'm thankful and grateful to you, sir, for providing us this opportunity and making this webinar successful. It's because of your efforts. It's because of your presence, your effort, your support matters us a lot. I'm thankful to Dr. Anil Kumar, Mr. Vinit Surana from SPIU Uttar Pradesh for their cooperation and for joint organization and for wide publicity of this particular webinar. So because of that, lot many participants, lot many persons from all over the country, they got benefited. Almost we got participation almost from all states of the country. So none of the state is left. So thank you very much for SPIU team and for their cooperation. I'm thankful to my organizing team, Dr. Atul Kumar for his technical support, Dr. D.K. Srivastava head and other faculty members who have directly and indirectly have supported me. I'm thankful and grateful to all the participants who have joined here through Zoom platform, through YouTube link, and